Alright, welcome back. This is our first official lesson on division of polynomials. But what you may not have realized is you've already been dividing polynomials in the previous videos. For instance, on the board here is a problem like what we've already done. Notice we have all multiplication. This is actually a monomial divided by a monomial. We can simply, when there's multiplication, we can simply cancel. X cancels with x squared, leaving an x. Y cancels with y, leaving a 1 and a 1. We don't write the 1's, and our final answer is 3x. Notice there is no addition in this problem. When there is no addition, things cancel very easily. Okay, so we can just simply cancel and get an answer. So yes, you have been dividing, but you've been dividing what? Monomial divided by monomial. And for instance, the original problem was described as a rational expression because there were variables in the denominator, but the final answer is just a monomial. Now, today you guys will be dividing polynomials that are involving addition or that involve addition. For example, let's look at this first problem, x squared plus 3x minus 40 multiplied by quantity x minus 5 to the negative 1 power. What you first have to notice is that we have a trinomial multiplied by a binomial that has a negative 1 exponent. And in reminding you, negative exponents mean move from numerator to denominator or move from the top to the bottom. So we're going to take this unit x minus 5, and you have to see that this x minus 5 moves where? This x minus 5 moves to the bottom. So the x minus 5 becomes x minus 5 on the bottom with a positive 1 exponent. So here we have x squared plus 3x minus 40 over x minus 5. So the x minus 5 moves to the bottom, and the exponent changes from negative 1 to positive 1. So you're looking at quantity x minus 5 to the positive 1, and we don't write the positive 1 power. So you see, do you see divide? Yes. Okay, so this problem is saying nothing more than divide. Okay, so we have a trinomial divided by a binomial, and technically the name for this, since there's a variable in the denominator, the technical name for this is a rational expression. Okay, so if I wanted to rename this lesson, instead of division of polynomials, we could call this lesson the study of rational expressions. Okay, so really, remember, everything in polynomials falls under the realm of rational expression. Now, there's another way to look at this problem. You can also think of negative exponents as changing multiplication to division. For instance, again, if I write 12 multiplied by 3 to the negative 1 power, remember we spoke of negative 1 exponents mean change multiplication to division. So we can look at this as 12 divided by, so the negative exponent changes multiplication to division, and the exponent becomes positive. 12 divided by 3 to the positive 1, and 12 divided by 3 gives 4. So we can also think of the negative 1 exponent as changing the multiplication to division. So we end up with x squared plus 3x minus 40 divided by x minus 5 quantity. Quantity x minus 5. So all three of these forms are saying exactly the same thing. We are on page 345 of the textbook, page 345, and the homework assigned for the first section, or the first problems assigned in this section, are numbers 20, 22, and 24 in the book. Now, I want you to see, on number 20, if you don't have your book in hand, you can see it here. On number 20, do you see division? Yes. On number 22, do you see division? Yes. These are how the problems are written in the book. So all three of these are saying exactly the same thing. Here you see divide. Here you see what? Divide. The negative 1 exponent means move this unit to the denominator. And here you see divide. So all three forms are simply saying divide. Now, let's look at this form in particular. Before we go into actually how to do these problems, let's look at this form in particular. The question is, can we cancel x with x? Okay, the question is, will the x cancel with the x? And the answer is no. The x's do not cancel, and we're going to talk more about this in the next video, but for right now I need you to know this. When did x's cancel? The x's canceled when you had 3x squared y divided by xy. When everything was multiplication, things canceled. So x canceled with x squared, leaving what? X. Y canceled with y, leaving 1 and 1, and we had an answer of 3x. Why did things cancel? Because you had operation multiplication. Things only cancel when there's multiplication. Notice, in this problem we have addition, separating our products. So on top we have addition of x squared, 3x, and negative 40. Think of addition as jail bars. Okay, addition locks up every unit left and right. So the addition locks up the x squared and the 3x. Okay, the negative or the subtraction locks up the 3x and the 40. So the 3x is locked up twice. The x squared and the 40 are locked up once. The addition on the bottom locks up the x and the 5. So everything is locked up. When it is locked up, it means they do not cancel. So does the x cancel with the x? No. Why does it not cancel? Because there's addition locking up the terms. Everything is locked up and nothing cancels. So my question is, does the 5 cancel with the 40? No, because addition is locking up the 40 and the 5. So there's another technique to this. So let's go ahead and rewrite the problem. X squared plus 3x minus 40 divided by quantity x minus 5. We do this old school. So we're going to look at two methods to actually simplify this. So the rules for simplification, when there's addition, or I should say more specifically, when there is a binomial in the denominator, the rules go as follows. We use what's called long division. Okay, old school. We're going back to elementary school now. Long division, except you're doing this with x. So we're looking at x squared plus 3x minus 40 divided by x minus 5 old school. Now, going back to what you guys learned in elementary school, for instance, if I write on the board, this is an example. If I write 842 divided by 2, what you guys did in elementary school was ask the question, how many times does 2 go into 8? How many times does 2 go into 8? Well, you answer 4. 2 goes into 8 4 times, and now what do we do with the 4 and the 2? We multiply. 4 times 2 gives 8, then we subtract. 8 minus 8 gives us 0. We bring down the 42 and start the process over again. But we're changing the question today. So you guys asked this question up to this point. You said, how many times does 2 go into 8? That is not the question today. The question is different. Instead, we're going to ask this question. Put a question mark here. Okay, so question mark. What? The question is, what multiplies by 2 to give 8? What will multiply by 2 to give 8? And answer that question. So if you ask what multiplies by 2 to give 8, you answer the question, you get what? 4. 4 multiplies by 2 to give 8, and now what do we do with the 4 and the 2? We multiply. 4 times 2 gives 8, and after we multiply these, we subtract. So 8 minus 8 gives us 0, and we bring down the 42 and start the process over again. So what we're going to do today is ask what. What multiplies by the front to give the front? What multiplies by the front to give the front? And if you spent a long time doing the simplification portion, the previous videos, simplifying polynomials, this question becomes very easy. What multiplies by x to give x squared? What multiplies by x to give x squared? Just like we asked the question, what multiplies by 2 to give 8? Okay, so if you struggle with this, you can take x squared. You can take x squared and write it as x times x, putting a box around it. Okay, so the question is what? I'm putting a question mark over it. What's in the box? What multiplies by x to give x squared? And hopefully you can answer. The question is just x. Okay, so x will multiply by x to give x squared. So this is the answer to the question. Just like 4 will multiply by 2 to give 8. So once we answer the question, x multiplies by x to give x squared, we now take the x and we multiply by the x minus 5. Just like we took the 4 and multiplied by the 2 to get 8. So now take the x and multiply by x minus 5. Here this is a monomial times a binomial. So we have x multiplying by x minus 5. And what happens when multiplication meets addition? When multiplication meets addition, distributive property applies. So we're actually going to take the x and multiply by both terms. So taking monomial x, multiplying by binomial x minus 5 is written like your eyes are used to seeing it as x times quantity x minus 5. We now take the x and multiply by both. X times x gives what? X squared, and x times negative 5 is negative 5x. So can you see it here? Take the x and multiply by both. X times x is what? X squared, and x times negative 5 is what? Negative 5x. And now once we get the result down here, what do? We subtract. So we did 4 times 2 and got 8, and now we subtract. So we do this product, now subtracts. We're subtracting both. Parentheses are necessary. So put the parentheses. We don't like to subtract, we like to add. So we're going to change this to addition, change the signs. Well, let me write this horizontally. I think this will make more sense. you're looking at here, this looks like what we looked at in the last videos, x squared plus 3x minus 40, subtract quantity x squared minus 5x. If I write it like this, your eyes are used to looking at it. You have a trinomial subtract a binomial. Now, we don't like to subtract, we like to add. So we're going to change the signs of the terms, make this negative, make this positive, and now add. And x squared plus negative x squared cancel out. 3x plus 5x, when we add, something must match, and what matches doesn't change. 3x plus 5x is what? 8x, and we have a minus 40 left. So 8x minus 40. Now, we're going to do the same thing here. We don't like to subtract, we like to add. So we're going to take the negative and distribute, make this negative, make this positive, and now add. Okay, so x squared plus negative x squared, what happens? What matches doesn't change. The x squared does not change. What is 1 minus 1? Or 1 plus negative 1 is what? 0. So we get 0x squared, which is just 0. So we don't actually write this. We say that the front terms cancel. Your leading terms should always cancel. If they don't, you did something wrong. So the first terms cancel. Now 3x plus 5x. Do the x's match? Yes, so you can add. The x does not change. 3 plus 5 is 8. So we have 8x. Now bring down the negative 40 and start the process over again. Once we bring down over here, once we bring down the 42, we start the process over again. We ask the question, what multiplies by 2 to give 4? What multiplies by 2 to give 4? Hopefully you say 2. 2 times 2. Now we take the 2 and multiply by the 2. 2 times 2 is 4. Subtract. This gives us 0. Bring down the 2 and start the process over again. So you're asking, what multiplies by the front? What multiplies by the front to give the front? Or what multiplies by x to give 8x? You're just concentrating on the front. Ignore the 5 and ignore the 40. What multiplies by x to give 8x? If you have to do this, take your 8x and write it. 8 times x. Put a box around the 8. Okay, so what multiplies by x to give 8x? Hopefully you can look here and say, what's in the box? Well, 8. So 8 will multiply by x to give 8x. Now take the 8 and multiply by the x minus 5. What happens when multiplication meets addition? 8 times quantity, x minus 5. When multiplication meets addition, distributive property applies. 8 times x is what? 8x. 8 times negative 5 is negative 40. And we are now going to subtract both. So put parentheses. We don't like to subtract. We like to add. So change the signs. Make this negative. Make this positive. And now add. 8 plus negative 8 cancels and gives what? 0. Okay, so the front term should always cancel. And what is negative 40 plus 40? Negative 40 plus 40 is 0, and we call this the remainder. So we get a remainder of 0, and our answer is, the answer is x plus 8. This is your answer. Now, we're going to look at long division first, and now a second process. Okay, so long division takes a while. Okay, this takes a while to do the problems. When you guys get to pre-cal, math courses beyond this, you will spend... Do you want to do your, or I should say it like this, do you want to spend 2 hours doing your homework, or do you want to do your homework in just 30 minutes? Okay, so if you had to do long division for every problem in pre-cal that you're going to encounter, your homework would take you in excess of 2 hours up to 3 hours. However, we have a trick to make this a lot faster. We call this trick synthetic. Synthetic means fake. Okay, so synthetic division is fake division. We have synthetic division, and to do this process, this makes it a lot faster. Let's look. We look at the largest degree of the dividend. So we start with the dividend. What's largest degree of the dividend? Remember, degree is your exponent. What's largest degree? Largest degree is second degree. So we have second degree, first degree, and 0 degree. Largest degree is second degree, so we write x squared, and then all the way down to 0. So x squared, then what? X to the first. So x squared, x to the first, and x to the 0. So we represent all degrees of x in the dividend. What's underneath the division symbol. Okay, now, underneath the x squared, we're going to put what's in front of x squared. What's in front of x squared? Hopefully you say there's a 1 in front of x squared, so we put a 1. And what's in front of your x term? Hopefully you say 3, so we're going to put a 3 underneath the x. And what is the x to the 0? Remember, x to the 0 represents your constant. We don't write the x to the 0 because x to the 0 is assumed to be 1. So what is your constant term? Your constant term is negative 40. And now we put a little half box over here. And in the half box goes the number in the divisor. Or I should say the opposite of the number in the divisor. So what is the divisor? The divisor is x minus 5. What is the opposite of the number? Here we have negative 5 in the divisor. Take the opposite of this, which is positive 5. So in the box goes positive 5. And now we're going to start a process. In order to do this process, students must remember the first thing you need to do is bring down the 1. So bring down the 1. And now the process goes like this. You multiply, then add, multiply, then add, multiply, then add, multiply, then add, and you're done. So multiply, then add, multiply, then add, multiply, then add, and you're done. So the question is, do we multiply first or do we add first? I tell students, please excuse my aunt. Okay, so the acronym, do we multiply first or do we add first? Well, hopefully you say we multiply first. So do we multiply or add first? We multiply. Okay, so multiply, add, multiply, add, multiply, add, and you're done. So we're looking at what? First multiply. Take the 5, multiply by the 1. 5 times 1 gives 5, and put that here. Now add. 3 plus 5 gives 8. Now multiply. 5 times 8. 5 times 8 is 40. Put this here. Now add. Negative 40 plus 40 gives 0. Up here we had x squared. Go 1 degree below. 1 degree less than x squared. So 1 degree less than 2 is first degree. So down here, 1 degree less is x to the first power, x to the 0 power, all the way down to 0, then your remainder. Okay, so x to the first, x to the 0, the remainder. Then the answer has to be glued back together. We have 1x, so we're just going to write this as x. We don't write 1x, we just write x. And 8x to the 0. So we write 8x to the 0. Do we have to write the x to the 0? No. X to the 0 is assumed to be 1. And our remainder is 0, so we don't write it. And our answer is x plus 8. Notice that x plus 8 matches x plus 8. If you're looking at this example on the board and you say, I have no clue what's going on here, wait until the next example. I think this becomes very easy once you see a couple different problems. All right, so next example. We're looking at let's see, 2x cubed minus 13x squared plus 26x minus 25 multiplied by quantity x minus 4 to the negative 1 power. Now, what are you looking at? Hopefully you look at this and say, well, that's division. What does that negative 1 exponent mean? That negative 1 exponent means that this binomial moves where? To the bottom. So we're actually looking at 2x to the third minus 13x squared plus 26x minus 25 divided by x minus 4. So the x minus 4 moves from the top to the bottom, and the exponent changes from negative 1 to positive 1. So we're actually looking at x minus 4 to the positive 1 power. Now, hopefully you see division. And in order to divide this, because there's addition, remember addition does what? Addition locks up every term left and right of it. Okay, so addition locks up every term left and right. Addition locks up every term. So is the x free to cancel with the x on top? No. Okay, is the 4 free to cancel with the 2? No. Why? Because addition is locking everything up. So if there is addition in the problem, you guys have to use a technique called long division. So either long division or synthetic division. So long division says we're going to take 2x to the third minus 13x squared plus 26x minus 25 and divide by quantity x minus 4. So it's the top divided by the bottom. And now we ask the question, what? Question mark. What multiplies by the front to give the front? Or what will multiply by x to give 2x to the third? All right, so you write 2x to the third. 2 times x times x times x. Take your 2x to the third and write it out like this. Now we're asking what multiplies by x to give 2x to the third. Take an x out of this and put a box around the rest of it. Okay, so now look what's in the box. What in the box will multiply by x to give 2x to the third? Well, hopefully you say, well, we have a 2 and a couple x's in the box, so what's going to multiply by x to give 2x to the third? That would be 2x squared. Okay, so 2x squared will multiply by x to give 2x to the third. Why? Because we want the front to match. And why do we want the front to match? So that the front will cancel. So now we're going to take our 2x squared and multiply by the quantity x minus 4. Remember that the 2x squared multiplies by what? Both. So 2x squared times x gives 2x to the third. And 2x squared times negative 4, be careful, 2 times negative 4 is negative 8x squared. And now we are subtracting what? Subtracting both. Put your parentheses around it. We don't like to subtract, we like to add. So we're going to change the signs, make this negative, make this positive, and now add. So we have 2x cubed plus negative 2x cubed. The x cubed does not change. 2 plus negative 2 gives what? 0. So we get 0x cubed, which basically means it cancels out. This is nothing. Remember, your front should always cancel. If your front does not cancel, you did something wrong. Now, does your x squared match your x squared? Yes. When we add, what matches doesn't change. The x squared does not change. Negative 13 plus 8, since the signs are different, you're technically subtracting. 13 minus 8 is 5. And take the sign of the larger, which is negative. So this is negative 5x squared. Now bring everything down and start the process over again. So bring down the 26x minus 25. We start the process over again. We ask what? What multiplies by the front to give the front? Or what multiplies by x to give negative 5x squared? Okay, if you need to, take your negative 5x squared and write it out. Negative 5 times x, put a box around everything except the x. What in the box will multiply by x to give negative 5x squared? Hopefully you say, well, that would be negative 5x. So we're going to have negative 5x. Negative 5x will multiply by x to give negative 5x squared. Now we're going to take the negative 5x. We're going to take the negative 5x and multiply by what? Multiply by both. So negative 5x times x gives negative 5x squared. And negative 5x times negative 4, be careful, negative 5 times negative 4 is positive 20x. And now we are doing what? Subtracting both. We don't like to subtract, we like to add, so change the signs, make this positive, make this negative, and change this to addition. Negative 5x squared plus 5x squared cancel out. This is 0. And 26x plus negative 20x, since we have opposite signs, we subtract. 26 minus 20 is 6x. Take the sign of the larger, which is positive. Bring down the negative 25 and start the process over again. Hopefully at this point you're starting to get comfortable with this, in that what, we're asking the question, what multiplies by the front to give the front, or what multiplies by x to give 6x. At first these problems seem quite monstrous, I guess, as far as the amount of work you have to do. But once you do it a couple times, it actually becomes very easy. I think you guys will find this to be quite simple once you get the hang of it. So what multiplies by the front to give the front? Or what multiplies by x to give 6x? That's what? A 6. So now we're going to take the 6 and multiply by both. 6 times x is 6x. 6 times negative 4 is negative 24. And we are subtracting both. Put the parentheses, make this negative, make this positive, and now add. 6x plus negative 6x cancels, becomes 0. Negative 25 plus 24 gives what? Negative 1. Since the signs are opposite, we're subtracting, and this is our remainder. So here we end up with a remainder of negative 1. And what do we do with a remainder? Well, if I remind you, 15 divided by 4. How many times does 4 go into 15? Hopefully you say 3 times. 3 times 4 gives 12. Subtract, we get 3. Okay? So what do we do with our remainder? Our remainder is 3. So we say our answer is, this is a bad example. How about 21 divided by 4? How many times does 4 go into 21? 5 times. 4 times 5 is 20. Subtract, we get a remainder of 1. Now, where does the 1 go? Well, our answer is 5, and the remainder of 1 goes over the divisor 4. So we take the remainder, which is 1, and put it over the divisor, which is 4. We get 5 and 1/4. So what are we going to do with our remainder? We're going to take our remainder and put it over what? Over the divisor. So we're going to have plus negative 1 over x minus 4. Why the addition? Because 5 and 1/4 can be written as 5 plus 1 over 4. So we can take the remainder over the divisor and write 5 and 1/4 as 5 plus 1/4. So we're adding what? We're adding the remainder, which is negative 1 over the divisor x minus 4. So plus negative 1 over x minus 4. And the negative can actually float out front. This negative can float out front, changing the addition to what? Subtraction. So instead of plus negative 1, let the negative float out front and make this subtraction. So we have minus 1 over x minus 4, and you are done with the problem. This is your answer. Now the question is, are we going to get the same answer if we do this using synthetic division? And yes, we will, but let's see it. Okay, so the first, I think this one makes the synthetic division more clear. So write synthetic division, this is fake division, or a trick that makes this much faster. Watch how much easier synthetic division is. Now tonight on your homework, you're required to do both methods. Why both methods? Because when does synthetic division work? Synthetic division works only for binomials of first degree. I'm not going to get into this, but it doesn't always work. Synthetic division does not always work, but long division always works. So you have to know the method first that will always get you an answer. What happens when synthetic division does not work? You have to revert to what? Long division. Okay, so synthetic division, we start with what? Synthetic division, we start with our dividend. Okay, largest degree of the dividend. Okay, our largest degree here is third degree, or x to the third power. So we have what? X to the third, and go all the way down to 0. We have x to the third, x squared, x, and x to the 0. And now we put in our constants. What's in front of our x to the third term? Well, you have a 2. So we're going to have 2 underneath the x to the third. And we have a minus 13x squared. So what's in front of the x squared term? This is a minus 13. Now, what is in front of your x term? Hopefully you say 26. So we have 26, and what is our constant? Our x to the 0, or our constant term, is negative 25. This goes here. And now put your little half box over here. Inside of this box goes the opposite of the number in the divisor. In the divisor, we have a negative 4. The opposite of negative 4 is positive 4. So we put a positive 4 in this box. And how do we start this process? This is what you must remember. In order to start this process, you have to start by bringing down the 2. Okay, so bring down the 2 first. And the question is, do we multiply or do we add first? Multiply or add? Hopefully you say we multiply before we add, so we start with multiplication. 4 times 2 is 8. And now add. Negative 13 plus 8. Since the signs are different, you're technically subtracting. 13 minus 8 is 5. Take the sign of the larger, which is negative. And now multiply. 4 times negative 5. 4 times negative 5 is negative 20. Now add. Since the signs are different, you're technically subtracting. 26 minus 20 is 6. And now multiply. 4 times 6 is 24. Now add. Negative 25 plus 24 is negative 1. And now up here we have third degree. X to the third. On the bottom, your degree is 1 less. So go 1 degree less than third degree. 1 degree less is what? X squared, then what? X, then x to the 0. So x squared, x to the 0, all the way down to your remainder. Okay, now glue it back together. We don't write our final answer this way. Glue it back together as 2x squared minus 5x plus 6x to the 0. Do we write the x to the 0? No. You guys should be comfortable at this point that this is your constant term, just plus 6. And we have a remainder of negative 1, so this is minus 1 over the divisor. Over the divisor. Since we have a 4 in the box, the divisor is x opposite the 4. So opposite the 4 is what? Minus 4. So we have minus 1 over x minus 4. And that concludes this lesson. Good luck with your homework. In the next lesson, we will finish this topic and go a little deeper.